Hi class, welcome to your first video for Math 138. We're going to jump right into chapter 1. We're going to skip a video lecture for section 1.1 and go right into section 1.2. And this section is called Geometry, Mathematical System. So we have two objectives in this short lecture video here. The first one is we're going to use logic to recognize patterns, and I'll do a couple examples. And then we want to understand how a mathematical system like geometry is formed. All right, so we'll start with some definitions. All right, so the word geometry comes from the Greek language and it means to measure the earth. And that's what you would think of, right, when you think of geometry, right? It's like shapes, objects, measurements of some type. But before we talk more about geometry and mathematical systems, let's check our reasoning skills or logic, because we're going to be doing some proofs in this class later on and we want to have some good logical skills to be able to prove things. All right, so we need to learn how to use reason and logic in order to recognize patterns, make conjectures, and develop the laws of this system of geometry. All right, so let's use some logic here. All right, and this is about recognizing patterns. Let's sketch the next figure in this pattern. So it looks like I have a square, and I have this shaded area here that's moving from this corner to this corner, now down to this corner. So if you were to, conjecture or think or deduce what would happen next, that what I think we'd want to see is this move to this corner here. All right, so from right to left, each figure is a square with the triangle shaded in a different corner. From left to right, the shading is moving clockwise. Thus, we predict, just like how I said, we'd have this shaded region right over here. All right, now let's do it with numbers. Let's look for a pattern to predict the next number in each one of these. All right, so we have the numbers. The first one we'll do, we have 2, 10, 50, 250. Like what, even before I show the answer, like on your own, maybe think about what you would predict to be the next number. Well, here's what I'm knowing. 2 times 5 is 10, 10 times 5 is 50, 50 times 5 is 250. So it looks like we're getting multiplied by 5. So each number is 5 times the previous number. We predict the next number, 250 times 5 would be 1,200. All right, let's try this next one. So -3, 0, 3, 6, and 9. So if you're thinking here like, oh, well, what's the weird pattern here? Well, it looks like -3 to 0 is 3, and 0 to 3 is 3, 3 to 6 is 3, 6 to 9 is 3. So going by adding by 3. So each number is 3 more than the previous number. So we predict the next number to be 12, because 9 plus 3 is 12. All right, let's just do some definitions. Now we can use our logic and reasoning skills to develop a mathematical system of geometry. So first we begin with undefined terms, which we want to first describe. We're going to use these undefined terms to formally define terms. And I know that seems so weird, like what the heck do you mean? All right, well, we use our defined terms to write statements that we do not prove, but instead agree and accept on them to be true. These statements are called postulates or axioms. Like a postulate axiom is a right angle is a 90-degree angle. We're not going to prove it, but we're just going to take it to be true. So our mathematical systems grows by using terms, postulates, axioms, these things to prove theorems. All right, so undefined terms are the most basic of terms that we do not formally define, but have a meaning or description that we agree upon. To form definitions, we use undefined terms or already defined terms to formally define them. All right, so what are these postulates or axioms? These are statements that we accept as true and do not prove. And theorems are statements that we prove using logic, the foundation above, and other previously proved theorems. All right, so be careful. I want to talk about figure assumptions here because we're going to be looking at figures a lot in this class. So be careful when assuming anything from a marked or unmarked figure. Right? Like, can you assume that this is a line? Well, it's straight and it has arrows pointing on, and that means it goes this way to infinity and this way to infinity. So yes, we can assume this is a line. However, can we assume this is a right angle? I mean, it looks like it. But we actually cannot, right? The reason being is if there's no, and I'll show you the notation here, if there's no box here, we don't know for sure this is a 90-degree angle. Maybe this is an 89.95 degree angle. All right, so is this a right angle? Well, whenever it has this rectangular box in here, this square here, that's telling us indeed this is a 90-degree angle. So yes, we can assume this is a 90 degree. Are these angles supplementary? They sum to 180 degrees. Well, we're talking about this angle here, this angle here. Well, yes, because they're formed, these angles are formed by a vertical line here, excuse me, a horizontal line here. Yes, we can assume they're supplementary. Do these angles have a common side? So this angle here, this one right here, and then this angle here. So in here and in here, yes, they do have a common side. It's this one right here. All right, these two lines intersect to form angles. Well, obviously they do. Here's one angle, here's another. So yes, they do intersect to form angles. All right, these angles are complementary. They sum to 90. What do you think? No, even though we might think it's not, because it doesn't have that rectangular box here. It tells us that's a 90-degree angle. So these angles are complementary. Yes, because they do have this angle and this angle here. When you add them together, you do get that 90-degree angle. So yes, they are. All right, are these segments, do they have equal length? They kind of look like they do. But don't just assume that they do. No, no. We don't know exactly how long this one is and exactly how long this one is. But if we've shown them like this, these segments have equal length. Well, there I'm telling you that they're both 1 inch. So yes, indeed they do. All right, one last one. Given the figure, can you conclude, can you conclude this statement? This is a square. Well, even though it looks like it, no, we cannot assume the figure is a square. A square has 4 right angles and 4 sides of equal length. So correctly marked, this is a square. This is telling us that this, and this are 90-degree angles, right angles, and 1 dash, 1 dash, 1 dash, 1 dash. These dashes through each side tell us that the sides are equal length.